oxygen. 40% to 60%. You might even see the ratio straight away. Does that come out of anyone? Yeah? Let's see what we're going to do. Sulfur. Divide your sulfur by, get the number of moles. So assume this percentage is sort of a mass. So divide it by its relative molecular mass and divide oxygen by its relative molecular mass, and we'll get two figures. 40 divided by 32, that gives us 5/4, which is 1.25. And 60 divided by 16 gives us 3.75. Okay, so those are my two numbers. Now I've got to get the ratio. If I'm unsure, take the smallest one and divide both of them by it. So the smallest ratio here is 1.25. So sulfur to oxygen, what's my smallest whole number ratio now? What do you think? 1:3. Can you see that? Okay, so we'll take the 1.25 and the 3.75. We'll divide both of them by the smallest one. So this is the smallest one. And this 1.25 over 1.25 is 1. And 3.75 over 1.25 is 3. So my empirical formula is 1 sulfur atom and 3 oxygen atoms. And then I just show that as an empirical formula by just writing brackets and an N outside it. Okay. I'll do one more. And then, yes? We've got 3 elements this time. And the percentages of them present are 23.7% sulfur, 23.7% oxygen, and the chlorine is 52.6%. Okay, so these are the percentages of the elements present. I'm looking for the empirical formula. So I'm going to take the percentage, the 23.7, and divide it by its relative molecular mass. For sulfur, that's 32. For oxygen, 16. And for chlorine, 35.5. And then I work those 3 figures out and look for the smallest whole number ratio. So 23.7 divided by 32 will give me 0.74. 23.7 divided by 16 will give me 1.48. And 52.6 divided by 35.5 will give me 1.48. Okay, so now I'm going to do the ratio. So what have I got? Sulfur to oxygen to chlorine. And I've got 0.74, 1.48 and 1.48. So I take the smallest one of them, which is 0.74, and divide each of them by that number. So 0.74 is the smallest. And this will go in once, twice, twice. That's clear. So I've got